Okay, so this week, I can go ahead and show you guys what our assignments are while we're waiting on the rest of the class to join. Oh, by the way, I want to mention the pickleball permission slip for your parent to sign and send in. The last day of school, May 30th, is our last day of school because of the snow days. We got pushed to that Tuesday after Memorial Day. And so we said, well, got two different things, two options. It's nice to have options. You have options. Option number one is you can come play pickleball against the staff. We're going to have a staff versus students pickleball time. And we're going to be having that at one of the parks. So there's information. There's the permission form. And underneath here is the flyer about the little pickleball tournament. There you go, at the Bentonville Community Center. From 10 till noon. We have snacks and water there. If you have a pickleball paddle, bring one. I don't know how many pickleball players there are out there, but bring it. The parents need to turn in your permission slip, and you need to be able to get there because you're all at different houses, so you need to be at the computer center. If that does not appeal to you, you're like, no, I don't want to do that. Then we will have some classwork for you, and through your advisory classes, we will have some work for you to do. So it'll be some ACT stuff for you guys. So you got options on the 30th, that last day of school. You can either do some schoolwork or you can complete pickleball with us. So, too bad my parents aren't around to sign my permission slip. That's all right. Here we go. I'm probably old enough to sign my own now. Let's look at what this week has. We have 2 assignments. Here's our notes. If you want to print those out, we're going to be doing these close class notes together here very briefly. I don't know if I'm going to do both pages. Yeah, I'll do some of those. Assignment number 1 is a formative over multiplying and dividing rationals, which we're about to go over. And then you have the Unit 5 quiz. We're done with Unit 5. Next week is finals. So we have the last assignment and then the quiz over what we've done the last 3 weeks. This week and the last 2. So you have an assignment and a quiz. So I just wanted you to be ready for that. So to prepare you for that quiz, I do want to do one problem here that we didn't really talk about last week. Last week we were doing rational functions. You remember talking about how to find the x-intercepts, the vertical asymptotes, horizontal asymptotes, any holes that are in the function or anything like that. And we had examples of problems. We had the equations, and we would find out all the good information over there. So we did several of those last week. But what if I gave you this problem? I says, I want you to write the equation. So you would be writing an fx for a function that has an x-intercept at 3, 0, and vertical asymptotes at x equals 3 and x equals -4. You're like, I don't know. Well, remember, they all have fractions in them. I mean, it's a polynomial, P over Q, polynomial over polynomial. Well, this tells us a lot. X-intercepts. How do we find x-intercepts? Find the x-intercept by setting the numerator equal to 0. The numerator. So if the x-intercept is at 3, that means x equals 3. If we set that equal to 0, we'd have to move this to the other side. So x minus 3 equals 0. So the numerator is x minus 3. Because when you set x minus 3 equal to 0, x equals 3. So that would mean that would be the x-intercept when we set the numerator equals 0. So that satisfies the x-intercept. Now, what about the vertical asymptotes? Well, for those, you set the denominator equal to 0. So that tells us what's going to go on the bottom. So if both of those were set to 0, x equals 3. If we set this equal to 0, we're going to move the 3 to their side. So that's x minus 3 equals 0. So there's also an x minus 3 on the bottom. Same as the top. Oh, that wouldn't work. because you're going to have an asymptote and an x-intercept there. Let's change this number because I gave you a problem that would not exist. Let's say it's 5. So this would be x minus 5 because there wouldn't be an asymptote at an intercept. So I'll give you a bad example. Vertical asymptote at 5 and -4. So x minus 5 would be one of the binomials, and the other one, x equals -4. So if we move the 4 over, x plus 4 equals 0. This must be x plus 4. So this is a rational function that would have an x-intercept at 3, 0, and vertical asymptotes at x equals 5 and x equals -4. That's it. That's the final answer. You don't have to do anything else. You don't have to combine those. In fact, I recommend don't. Don't just leave it like that. That's fine. Leave it in factored form. And that's as easy as it is. X-intercept at 3, 0, vertical asymptotes at 5, -4. There will be a problem like that on the quiz this week. So I want you to know how to do that. Remember, x-intercept is the numerator. Vertical asymptotes is based on denominator. And that should have been in your notes last week anyway. So you should already have this in your notes. But I just thought I'd make sure you know exactly how to use that, because we kind of went the other direction. We were doing this, finding those. Now I'm giving you those, finding this. So, all right. So let's look at this week's multiplying and dividing rational expressions. Okay, a little bit different than what we had last week. This is what your assignment's going to look like. So if we were going to simplify, so here's our directions. Simplify and state the excluded values. Oh, excluded values. Okay. So simplifying is done with the numbers and the variables, right? 12 over 30. Well, we can divide 3 into both of those. So that simplifies to 4 over 10, which still simplifies further, right? Because 4 over 10 is the same as 2 over 5. So we could take a 6 out of each of those. We can simplify it twice. K to the third over k squared. So this is k times k times k. The bottom is k times k. Well, k divided by k is just 1. Those cancel each other out. K divided by k is 1. So all that's left is a k on the top. So this simplifies to 2k over 5. 2k over 5. That's our answer. That is the simplified. Now we have to state the excluded values. If we look at this, k cannot be 0. Because if k is 0, then 30 times k squared is 0. And this doesn't exist because you cannot have 0 in the numerator. No 0 in the denominator. I'm sorry, the denominator, not the numerator. So whatever would make the bottom equal 0, we can't have, which this is just one term. So let's look at this one. Very similar to this one. And we'll do this one on blue. So 24 over 36. That can be divided by 12, both of those. So that would be the same as 2/3, right? A over a squared. We got an A, we got an A times A. So that cancels out on top. All we have left is an A on the bottom, and it's 2 over 3A. And A cannot be, again, just a 0. All right, so far, so good. This ain't so bad. Oh, until we get here, now that looks a lot different than those up there. This one is going to have to be factored first. We have to factor that. So we have a 2 and a 21, which means we're going to divide it into a 42. We've got this 13x in here. So we're going to need to have numbers that multiply to be 42 and add up to be 13. So 42 is 7 times 6, which adds up to 13. That's nice. So we can break this out into a 2x squared plus 6x plus 7x plus 21. See, we just broke that 13 up, rewrote it as a 6 and a 7. That's the same thing as plus 13. Then we factor by grouping. So we can pull 2x out of that, which leaves x plus 3. We can factor a 7 out of this, 7, and that leaves x plus 3. So on top, we've got, I'm going to write it over here because I'm not going to do these problems. I'm not doing the blue one. So on top, we've got 2x plus 7, because that's right here. And we factored out an x plus 3 of both of them. And all of that's over x plus 3. So 2x plus 7 times x plus 3 over x plus 3. These cancel each other out. X plus 3 divided by x plus 3 is just 1. So the answer is 2x plus 7. So 2x plus 7 is what it simplified. But the denominator is x plus 3. That can't be 0. If it was 0, subtract 3. If x is negative 3, then the denominator would be a 0, and that's not allowed. X cannot be negative 3. So that ends up our answer right there. It simplifies to 2x plus 7, and x is not allowed to be negative 3. All right, that would be a hole that we talked about last week. If we get the same thing on top and bottom, that's a hole in the graph. So that would not exist in that graph. All right, what about this one? Ooh. So that's going to go into 7p squared plus 57p. So let's work that over here. Well, let's work that in some other paper. Let me just give me a little room here. 7p squared plus 57p plus 8. And we want to factor that. So 8 times 7 is 56. So what would multiply to be 56 and add to be 57? Well, that's pretty easy. So we can rewrite that as 7 squared plus 56p plus p plus 8. Right? 56 and 1 is 57. And that multiplies together be 56. 1 times 56 is 56, which is what these two multiply together. So if we group those, we can factor out a 7p, which leaves p plus 8. And here is just, we can factor out a 1 because it's still p plus 8. So this factors to 7p plus 1, p plus 8. And it's over, in our problem originally, there's over a p plus 8. So the bottom is still p plus 8. These two cancel out, so it just ends up simplifying to 7p plus 1. And p cannot be negative 8. So there you go. There's our answer. 7p plus 1. P cannot be negative 8. All right, let's look. I'm going to do the yellow ones here. We can factor a 3x out of that. So we got 3x over x minus 15. I mean, 3x times x minus 15, because that's what we get when we factor out 3x. Over, and we need two numbers that would multiply to be negative 15 and add to be negative 2. Oh, I'm sorry. I factored a 3 out of that, didn't I? So if I factor a 3 out of the 15, I've only got x minus 5 left. Don't let me make mistakes here. So down the bottom, we've got x plus 3, x minus 5. Right? 3 minus 5 is negative 2. 3 times negative 5 is negative 15. These cancel out. And that just leaves 3x over x plus 3. That's what it simplifies to. But x cannot be what? Well, we had two things on the bottom. We had x plus 3, so x can't be negative 3, and it can't be 5. So there's two things x cannot be, negative 3 and 5. And it simplifies to 3x over x plus 3. All right, I'm going to move one more of these, then we're going to move down to just the bottom part, which is a little simpler. All right, 16b minus 56. Let's see, we can take an 8 out of both of those. 8 over 2b minus 7. On the bottom, what can we take out of that? We can take an 8 out of that, can't we? 8 out of 24b is 3b, and 8 out of 64 is minus 8. So 8 divided by 8, well, that's just 1. So this just equals 2b minus 7 divided by 3b minus 8. Those are different. Those can't cancel out. You can put them in parentheses. And b can't be what? Wow, 24b minus 64. So let's set that equal to 0. 24b minus 64 equals 0. We move the 64 over. That's 24b equals 64. And 64 divided by 24, which would simplify to 8/3. So b cannot be 8/3. As we simplify that down to its smallest fraction. And we would leave it as 8/3. We would not convert that to a decimal because that would be rounding. We don't want to round it. So that's our answer right there. Okay, the bottom part of this is just simplifying. We don't have to worry about stating the excluded values. This is just simplifying. But we're doing some math down here. Division, multiplication. This is dividing and multiplying two rational expressions. So this is how it works. We're going to multiply first. When you multiply fractions, you just multiply straight across. 6 times 7x is 42x. 2 times 5x is 10x. So what's 42x divided by 10x? Well, we got to simplify. I mean, x divided by x, those cancel each other out. 42 divided by 10, what's in common there? Probably just a 2, because if it's 2 times 5 is the only thing that can be. So if we factor out a 2, that's our answer. The x is canceled out because it's x divided by x. X divided by x is 1. So this is 21/5 times 1. So that's the final answer. The x's got rid of themselves. How about this one here? Divided by. When you're dividing by a fraction, you change that to multiply and you reverse the fraction. The fraction becomes the inverse. You put the top on the bottom and the bottom on the top. So instead of dividing by 6/5, you're multiplying by 5/6. So 9 times 5 is 45. 9x times 6 is 54x. So that will simplify. You can divide 9 out of the top and the bottom. So the top is 9. So that'd be 5 over 6x. That's as simple as that gets. 5 over 6x. Here's another yellow one. Okay, this is multiplying. It's already multiplying. So what do we see? We see there's a k plus 10 and a k plus 10. One on top, one on bottom. They cancel each other out. There's a 5 on top and a 5 on bottom. So the bottom is canceled out. All that's left is on the top, which is 6k+ 8. which you also 6K plus 48 would not be a wrong answer. That's just multiplying the 6 into there. But these are the same thing. Those are the same thing. So either one of those could be the answer. I'd probably leave it as this one. 6 times K plus 8. All right, one left. We got to rewrite this. So this is actually, let's see, 10P over 2P minus 9 divided by 3P times, we turn this upside down, 3 over 3 2P minus 9. Since it says divide, we rewrite it as a multiply and reverse the second fraction. Reverse that. So 3 cancels out with 3. 2P minus 9 cancels out with 2P minus 9. So what's left? We got 10P on top, P times 3 on bottom. That's all that's left. But these P's actually cancel each other out. P divided by P. So it's just 10/3. Yeah, P cancels out P. I missed that one. P cancels out P. 10/3. All right. So your assignment is actually all these blue problems. That's why I didn't do the blue problems. Let me show you that. All right, here's all the blue problems. Simplify this, type what it is when it's simplified, and then say X cannot be whatever number. Simplify this. N cannot be. Simplify this. X cannot be this number. So you have those, and then after you do that, then the next page is just like the ones at the bottom. It's just simplifying. This is a division. This one's a division. These two are multiply. All right, so you see what cancels out. Remember this, you have to flip them upside down and multiply. And that's this week's assignment. Here is the quiz that you also have this week. I'll let you look at this. Let's go back to question 1. Remember these? I give you this function right here. I give you the graph. You tell me what's the domain, what's the range. Give me the horizontal and vertical asymptotes. What is the asymptotes? Here's another one. Same thing. I give you the equation and the graph, domain, range, vertical and horizontal asymptotes. Next page. List the transformations. Remember, it would be just 1 over x, but this one's -2 over x plus 3 minus 6. There's multiple transformations there. I see 4. And this one, if 1 over x is translated 4 units right and 2 units down, you write the equation. F of x equals what? The equation that would make this move 4 units right and 2 units down. All right, then the second half of the quiz, I give you some of these rational expressions that have P over Q, right? P of x over Q of x. You give me the x-intercept, vertical, horizontal asymptotes, any holes, domain and range. So there's where you type those numbers in, domain and range. Got another one here. Give me those 6 things, domain and range. And then here's that one problem I warned you about at the end. The rational function has an x-intercept at -2, 0, and vertical asymptotes at x equals 5 and x equals 1. You write the equation. F of x equals what? You write the equation that could represent this right here. So that's it. That's it right there. This is the end of the semester. We've got this week, and then next week is just finals. Next week is just finals. So we'll have the final available next Tuesday, and it'll be due next Thursday. So you'll have 3 days to do the final. If you want to be exempt, you can exempt this semester from Algebra 2. We couldn't do that last semester, but this one you can. You need to have any missing work in by Monday morning. I'm not coming here Monday morning at 7 a.m. I'm going through and assigning exemptions. So if your work is not in by Monday, if there's an in the grade book, it's missing. So get that turned in before Monday. You got all week to do it here. All week. And after that, you can still turn in late work until Thursday next week, but that's just for credit, not for exemption. So, all right. Any questions? Okay, well, we will see you guys later. This is an A week, so Wednesday and Friday we have class if anyone needs help with anything. And we will see you guys next time.